Hello everyone. Our topic today is relative velocity. Let's assume a car A is moving with a uniform velocity of 7 meters per second in a particular direction from Q, as shown in the diagram. And another car B is moving with a uniform velocity of 5 meters per second in the same direction from Q. That means car A covers a distance of 7 meters every 1 second, and car B covers a distance of 5 meters every 1 second. After 2 seconds, car A would have covered a distance of 14 meters, while car B would have covered a distance of 10 meters. At this point of after 2 seconds, car A is 4 meters in front of car B. That means the displacement of car A from car B is increasing at the rate of 2 meters every second. Now, velocity is the time rate of change of displacement, and we speak of the velocity of car A relative to car B, which in this case is of the value 2 meters per second. When the two cars move in opposite direction away from Q, we can see that the displacement of car A from car B after 1 second is 7 plus 5, which is equal to 12 meters. After 2 seconds, it will be 10 plus 14, which will be equal to 24 meters. After 3 seconds, it will be 21 plus 15, which is equal to 36 meters. The displacement of car A from car B is 12 meters every 1 second. So the relative velocity of car A to car B is 12 meters per second. As a rule, if two bodies are moving in the same direction with velocities of VA and VB respectively, then the velocity of A relative to B is given by VA minus VB. If VA is 7 meters per second and VB is 5 meters per second, velocity of A relative to B is V is equal to 7 minus 5, which is equal to 2 meters per second. When the two bodies are in opposite direction, when velocities of VA and VB respectively, the velocity of A relative to B in this situation is given by VA plus VB. If VA is 7 meters per second and VB is 5 meters per second, velocity of A relative to B is V is equal to 7 plus 5, which will be equal to 12 meters per second. There are situations where the two velocities are not parallel to each other. Suppose a ferryman wants to cross a river with his boat. In this situation, there are two component velocities. One, its own velocity across the surface of the water, which is the same whether the water is moving or not. And two, the velocity of the river. These two component velocity have a resultant. Looking at that diagram, if his intention is to move from point A to point B, and he does not take into consideration the velocity of the river when crossing, he will not arrive at his intended destination. For him to arrive at B, he needs to face the direction C, as if he wants to move from A to C. But his actual destination is B. This is because of the velocity of the river that will be acting on the boat, pushing it towards B. But finally, he will arrive at B as intended. Those who have ever crossed a flowing river in a small ferry boat would have noticed that the boatman has to point the nose of the boat upstream in order to make a course straight across the river. As mentioned earlier, there are two component velocity. From our diagram, that of the boat AC and that of the river DA. The resultant of both will be AB. Now let's take an example. An aeroplane is traveling due north at 1080 km per hour. A wind of 100 km per hour then starts to blow. From the east, find the velocity of the aeroplane relative to the ground. Both velocity are at right angles to each other. So this will be simple. Using Pythagorean's theorem, c square is equal to a square plus b square. We will substitute in our value 1080 square plus 100 square. In that case, when we square 1080, we will get 1,168,400. When we square 100, we are going to get 10,000. Adding this together, we have 1,176,400. Then we are going to find the square root. If we find the square root, we are going to get 1,084.6, which is approximately 1,085. So our final answer is 1,085 kilometers per hour. To find the direction, we are going to use tan theta is equal to y over x. Our y is 1,080. Our x is 100. Substituting and simplifying, we will get 10.80. Then we find the tan inverse of 10.80. We get 84.7. So in our diagram there, you can see where 84.7 is. Explaining direction, we cannot use that direction. So we are going to subtract that from 90 degrees and we get 5.3 degrees. Now we can describe our direction with 5.3 degrees. That will be north 5.3 degrees west or 5.3 degree west of north. Let's take another example. A ship X is sailing due west with a velocity of 40.0 km per hour. Another ship Y is sailing northeast with a velocity of 30.0 km per hour. Find the relative velocity of X with respect to Y by drawing. The first thing to do is to choose a suitable scale. Let's make it 5 km per hour represent 1 centimeter. Using this scale, 40.0 km per hour will be 8 centimeter and 30 km per hour will be 6 centimeter. Do not forget to draw a rough sketch before your real work. We were told in the question that ship X is sailing due west and ship Y is sailing northeast. Using the 4 cardinal points, you can see west. Now look at the position of northeast. That is 45 degrees from the north. The angle between them will be 135 because when you add 90 degrees to 45 degrees, you will get 135 degrees. Draw a straight line AB 8 centimeter. Now, with your protractor, measure out 135 degrees. Draw 6 centimeter from point B to C. Measure the line AC. If you have done your work correctly, you should have about 13 centimeter. Multiplying this by 5, converting back to kilometer per hour, we will get 65 kilometer per hour. To find the direction, draw the 4 cardinal points as shown and measure the angle theta with your protractor. If you have done this correctly, you will get approximately 70 degrees. That means the direction of the resultant is 70 degrees west of south or south 70 degrees west. If you like the video, give it a like and don't forget to subscribe. Bye.